You drag a highlighter across a textbook page, confident you're capturing the most important information. But the reality is, the moment you close the book, your memory of that bright yellow text fades away almost instantly. Rereading notes and highlighting paragraphs are forms of passive learning. Because the information is right in front of you, your brain processes it smoothly, but that smoothness creates a false sense of familiarity. You begin to recognize the text, which tricks you into believing you have actually memorized it. Cognitive science offers a more effective approach. True retention comes from the testing effect, the active process of pulling information out of your brain and spacing those tests out over specific time intervals. We are going to build a 4-step system to replace passive reading. By the end of this, you will have a daily routine designed to move facts out of your fragile short-term memory and lock them into long-term storage. Effective studying isn't measured by the hours you spend staring at a page. It is measured by the level of cognitive friction required to actually retrieve an answer from your own mind. Before you create a single flashcard, you have to build a conceptual framework. Memorizing a string of facts without understanding how they connect is a waste of time. To build that framework, we use the Feynman technique. Named after physicist Richard Feynman, this method takes advantage of the self-explanation effect. Read a section of your source material, close the book, and explain the core concept out loud. Use plain English, as if you were teaching a child who knows nothing about the subject. When you force your brain to organize information into your own words, you immediately discover the exact spots where your explanation breaks down. Dedicate the first 20 to 30% of your study time to this act of explaining. It builds the mental scaffolding you need to hold on to the specific facts you'll memorize later. Once you understand the broad concepts, you switch from building a mental model to actively testing your memory of the specific details. You do this through the blurting method. Put away all of your notes, open a blank document, and write down every single fact, date, and definition you can remember from the material you just read. Next, open your original text and compare it side by side with your blurted notes. Aggressively mark anything you missed, got wrong, or only partially remembered. This exercise strips away the illusion of competence. By forcing a side-by-side comparison, you confront exactly what you can and cannot retrieve under pressure, which is exactly what you'll need to do during an exam. The items you marked, your errors and your omissions, are the only precise data points you need to focus on. These specific gaps are the only information that should proceed to the flashcard stage. We use Anki as the software engine for this system. Instead of fragmenting your notes into weekly subdecks, create a single master deck. Use tags to organize your specific topics, so everything lives in one central database. When creating cards for your knowledge gaps, follow the minimum information principle. A common trap is overloading a single flashcard with a massive paragraph of text, which makes the card difficult to review and schedule. If you have a dense concept, strip away the excess words until you are left with a single, punchy sentence containing one core fact. The most efficient format is a close deletion, turning your sentence into a fill-in-the-blank question, isolating a key term. Pair these fill-in-the-blank questions with related images. Your memory is much more efficient at retaining visual than text-based information, and adding a picture gives your brain an extra anchor to grab onto. Smaller, single-variable cards are much easier for your brain to process. You review them faster and schedule them more accurately, which ultimately saves time and prevents study burnout. This graph charts the forgetting curve. Without reinforcement, retention of newly learned facts exponentially decays. By spacing out study sessions, you force your brain to recall the answer just before it's forgotten. This effortful retrieval eventually flattens the curve, stopping the decay. To configure your software for this, set a daily cap on your new cards to prevent overload, but leave your review cards uncapped. You want the algorithm to prompt you exactly when a fact is at risk of slipping away. Block out your daily routine carefully. Start with a 10-minute rapid recall warm-up of old cards, then execute a 30 to 50-minute focused retrieval sprint on your new material. This spaced rhythm ensures you are testing yourself at the optimal moment of difficulty. By forcing your brain to work for every answer, you convert fragile, short-term familiarity into ready recall that survives the pressure of an exam. We understand the concept first by explaining it, expose our weak points by blurting, isolate those gaps into simple flashcards, and space out repetitions with math. Skipping any one of these components compromises the whole engine. Flashcards fail if you don't understand the concept, and understanding fades if you don't mathematically space your reviews. This active workflow requires high cognitive friction. It demands effort, precision, and honesty about what you actually know, replacing the comfortable but useless methods of passive reading. Pull up your current study materials. Open a blank document, close your textbook, and run your first diagnostic blurting session right now.